1963. Since human performance is always influenced by the surroundings and the environment in which one lives, the General Electric Company felt it necessary to duplicate faithfully, for its four-man space station simulation test, a cabin which would be similar to that which design studies have indicated might be included within space stations of this general class and configuration. The cabin developed for the simulation program was 12.5 feet in diameter and 24 feet high. It was separated into two compartments. The lower living compartment was designed to convey a feeling of spaciousness and to maximize storage volume for necessary equipment and supplies. Pull-out drawers containing food for the 30-day mission were placed above the countertop. A small 2 cubic foot freezer accommodated diet supplements such as butter, several steaks, frozen apple pies, and tomatoes. A 0G type water dispenser was used for reconstituting freeze-dried foods. The lower bunk served as a lounge and supplemented the upper bunk, which was used for the 6-hour sleep shifts. The lavatory contains a shower, wash basin, and toilet. The center of most activity on the upper deck was the vehicle system's instrument panel. This panel was the result of a design study of space station display and control requirements. Specific behavioral tasks were located adjacent to the main instrument panel. These tasks were used on a daily basis for the measurement of crew performance. The cabin was moved from the manufacturing area into one of the three 39-foot diameter space environment simulators in operation at Valley Forge. This simulator contained the test artificial atmosphere. The atmosphere chosen for evaluation was 7 psia, composed of sea-level oxygen partial pressure with nitrogen as the inert diluent. This choice, the result of a detailed study relating structural penalty, leakage loss, fan power, fire hazard, and extravehicular operations, appears to be the best compromise between engineering, physiological, and operational requirements for such space stations. In order to evaluate the physiological effects of the 7 psia atmosphere, a medical test program was designed. Physiological tests were separated into two categories. The pre-flight tests were made to establish baseline data on each subject prior to entry into the cabin. A similar battery of post-flight tests was conducted immediately upon exit from the cabin before substantial physiological readaptation to the Earth normal environment could have occurred. The second category included those measurements which could be taken on a daily or periodic basis by the crew during the flight and which required equipment that could readily be expected to be contained within a space station. In addition, laboratory analysis of blood, urine, and feces provided data for the calculation of nitrogen, calcium, and water balance. The majority of the activities associated with these measures was contributed by the personnel and facilities of Temple University Medical Center. This joint participation of General Electric physiologists with Temple's clinical and research specialists in the areas of pulmonary, renal, and cardiovascular functions permitted an exceptionally extensive biomedical evaluation of the effects of this environment upon man. Each crewman underwent 4 days of testing at the Temple University Medical Center prior to the test. The extensive clinical study involved history, physical exam, routine hematology, and urinalysis. A variety of blood and urine chemistries, extensive ECG studies, audiometry, and a careful ophthalmological exam, including perimetry, were performed. The workup included complete pulmonary function studies, cardiac output by dye dilution, and venal clearance evaluation. Each of these tests was repeated after completion of the flight. In addition, Temple personnel trained the crew in the technique of venipuncture, thereby permitting blood sampling during the test. 24-hour medical surveillance was provided in the control room during the test. Using closed-circuit television and the communication system, coupled with the daily in-flight data readout, physicians on duty closely monitored each subject on a continuous basis. Subjective data of health, well-being, morale, and receiving its final briefing just prior to the beginning of the test was selected from 60 male volunteers, all of whom had professional backgrounds and experience in engineering. The crew, 4 in number, represented an average of 10 years engineering experience. Their backgrounds included either aviation or nuclear submarine experience. The stringent physical examination and the results of a battery of psychological tests and depth interviews indicated that these men represented a healthy, stable, intelligent, and highly motivated group. Entry into the 39-foot simulator was accomplished through the airlock. An environmental control system was constructed which regulated the gas composition, pressure, temperature, and humidity. Because the space cabin was not sealed, this ECS system ventilated the entire simulator chamber. The success of any complex program depends to a large extent upon the performance of a team of supporting personnel. Those individuals in this test who served as test monitors had control over all test activities. The role of the monitors was maximized in order that a high degree of task and equipment programming flexibility could be realized. For example, the monitors had control over all subsystem conditions, providing the opportunity to judge station management performance. Each task was controlled individually, providing programming latitude for such events as scheduled emergencies and equipment failures. Task panels were used for the evaluation of crew performance. A total of 11 basic psychological tasks designed to probe many aspects of behavior were used. These involved several types of vigilance behavior.